We'll talk about the quantitative methods summary. So we essentially will go through every single reading, and I will just highlight the most important points. I'll make you do some work also, so where there are problems to do, I will let you know. I will also do a lot of reading. The intent here is to help you remember. You can read on your own, I'm sure, and hopefully you've done this before, but sometimes when people hear things from somebody else, it just sticks. So here you need to understand the various concepts related to interest rates. Interest rates can be interpreted as the required rate of return. They can be interpreted as a discount rate and an opportunity cost. I'm not going to go through details. Those are available in the regular lectures. Plus, on your exam, it's quite likely that your MCQ simply says something like interest rates can be least likely interpreted as a discount rate, opportunity cost, and sunk cost. So 3 terms that sound quite good, of which only 2 are from this list. As investors, we can view interest rate as the sum of all these. Now, this is something that you learned early in quant, and now you can relate to this a lot better given that you studied fixed income, right? And one of the things that you'll realize through this review course is that many topics are connected with each other, and if you recognize those connections, then you will appreciate this material more. Interest rate is the sum of the real risk-free rate plus an inflation premium plus the default risk premium, a liquidity premium, and maturity premium. So these are all different kinds of risks, and the interest rate on, let's say, a corporate bond would represent a summation of these various risks. This particular component, the real risk-free rate plus the inflation premium, is also referred to as the nominal interest. All right. Next point is future value, present value calculations. I'm not focusing on the formulas here. I need to make sure that you know how to use the calculator. So if you haven't done this already, this is how you set your calculator to floating decimal mode. So do that. Floating decimal means that rather than your calculator being stuck on 2 or 3 or 4 decimals, it gives you the appropriate number of decimals whenever you do a calculation. If you invest 100 today at 10% compounded annually, how much will you have in 5 years? Make sure you can do this very quickly. I'd say you should be able to do this in less than a minute easily. So do this and make sure that you get the correct answer. So I'll just give you 30 seconds to do this as I go along so that you are actively listening and actively working through this lecture. All right, so hopefully you got this answer. Then the next concept is related to multiple compounding periods. You invest 80,000 in a 3-year CD. This CD offers a stated annual interest rate of 10%. When the stated annual interest rate is 10% and there is periodic compounding, then you have to divide by a certain number to come up with the rate for every period. Compounded quarterly means you divide this by 4, and the interest rate that you will plug in will be 2.5. Why is n 12? Because we have 3 years multiplied by 4 periods per quarter. The payment is 0 because nothing is happening in between, and you do your calculation and you get this number. One of the things that I want you to be good at is to have a rough sense for what is the correct answer. So if you get this answer, then this should look right to you because you have 80,000 compounding, in terms of the approximate answer, this is increasing at about 10% per year, slightly more than 10%. So if you do 80% over 3 years, increasing 10%, 10%, 10%, about 107,000 seems right. All right. What if we have continuous compounding? Then you need to know this formula. So the future value is present value. That's present value is the amount invested into e to the power of r. R is the interest rate in decimal. So for r, you will plug in 0.036, and n is the number of years. So it would be times 3. The way you do this on the calculator is, for this part, you do 0.036 into 3, and then second, and then e to the power of x. multiply all that by 50,000, and this is what you should get. Present value of an ordinary annuity, there is a formula for this, but I want you to use the calculator. So if this is the information given, this is the payments, 5%, N is 5. With an ordinary annuity, if this is times 0, the first payment is happening at the end of period 1, and so on all the way till the end of period 5. Here is what you plug in. 10 for payment represents this payment. 0 FV means that there is nothing at the end. So actually I should not say nothing at the end. What we have here is 10, 10 and so on, and then there is a 10 at the end. There is nothing other than that 10. So that's why FV is 0. You compute the PV and you get 43.29. Now before I go to the next slide, which will be annuity due, you tell me whether if I have an annuity due, similar information, but with an annuity due, the first payment will be at time 0. Will the present value be more than, less than, or equal to this? The present value will be more because it's same 10, 10, 10, but one period earlier. So given the time value of money, if you get your money sooner, then obviously the PV is greater. So you need to be good at this. When you know that we have an annuity due, the first thing you do is put your calculator into annuity due mode. And you do that using these keystrokes. You need to get good at that. And then you plug in the numbers the same way and notice that your PV is higher. And another important piece of advice is that when you are done with an annuity due question, put your calculator back into normal mode. If you don't do that, then you will have trouble later. And I've seen several students come to me and complain that they are not getting the right answer. The reason is that they put the calculator in begin mode and then forgot about it. So when the calculator is in begin mode, there'll be this little begin on top. Make sure that it's only in begin mode if you intend the calculator to be in begin mode. All right. Present value of a perpetuity. This is simply the cash flow divided by the discount rate. So you don't need the financial function, it's a regular calculation. So if you invest this and get 5% forever, what's the cash flow? It is $5. So another way of looking at it is that if you are getting $5 forever and your rate is 5%, then what's the present value? It would be 5 divided by 0.05. Present values indexed at times other than 0. An annuity or perpetuity beginning somewhere in the future can be expressed in present value terms one period prior to the first payment. So this is critical, another classic error. If this is time 0 and you have a perpetuity that starts, let's say, at time 8, and the perpetuity is $10 forever, and the discount rate is equal to 5%, then the present value of this is equal to 10 divided by 0.05, which is 200. This 200 is at period 7. It's one period before the period where the cash flow starts. And then how do you come up with the value at time 0? You take the 200 and discount back to 0. Okay, now you also can use the calculator for solving for interest rates, growth rates. Interest rates and growth rates are similar as far as the calculator is concerned. Here are some basic calculations that I want you to be able to do. A $100 deposit today grows to 121 in 2 years. What's the rate? So you can even do this mentally, but plug in the numbers and you should get 10%. Similarly, if you have a population that starts at 100,000 and in 2 years goes to 121,000, plug in the numbers and you will have a growth rate of 10. This will remind you of fixed income. If you invest 900 today, let's say in a bond, and receive 100 coupon at the end of every year for 5 years, this is the payment. In addition, you receive 100,000 at the end of year 5. What's the interest rate? So plug in numbers. This should look a lot like calculating the yield to maturity on a regular straight bond. So this is the answer that you should get. Okay, so that was a quick overview of the first reading. Now we move to the second reading. The first part of the discounted cash flow application is to cover net present value and internal rate of return. And you need to be really good at coming up with NPV using the calculator. And the keystrokes are shown right here. So make sure you can do this very fast. So I will pause for a minute and you plug in the numbers to make sure you come up with this NPV. All right, so make sure you are good at this and you practice this enough times that you can do this very quickly. Then the next related concept is the IRR. The IRR is the rate such that NPV is 0. If you are given cash flows like this, then you have to again plug into the calculator. Notice that you do not need to enter an interest rate because that's what you are computing. The IRR is called an internal rate because it's the rate based on the cash flow associated with the project. So plug in these numbers and you should get 13.11%. All right, money weighted rate of return. The most important point to remember here is that money weighted rate of return is essentially the IRR of an investment. You determine all the cash flows, plug those cash flows into the calculator, and you get your IRR. But the cash flows need to be at equal periods, right? Let's say, just for simplicity, that cash flow is happening every year, as is the case over here. There is a certain cash flow at time 0, then there is a cash flow at time 1, and then there is a cash flow at time 2, which is end of year 2. To compute the IRR, you plug in the numbers and you get an IRR of this. Now, what if there is a cash flow at the end of 3 months, then there is a cash flow at the end of 9 months, and there's a cash flow at the end of 12 months? Then what do you do? Then what you do is, then you define each period as a quarter. Let's say that the cash flow here is 10, the cash flow here is 15, and the cash flow, actually let's say minus 10, money being spent, and over here the cash flow, let's say, is 30. So what will you plug in? You'll plug cash flow 1 is minus 10, cash flow 2 is 0. The classic mistake would be to put in minus 15, but every period has to be equally spaced. So cash flow 2 would be 0, cash flow 3 would be minus 15, cash flow 4 would be 30. Then the IRR that you get would be a quarter rate or an annual rate? The rate that you will get will be the rate for a quarter, because each period is a quarter. The calculator doesn't know that the period is a quarter or a year. So the calculator just treats this as your period now. So the rate will be for this period, and you need to then multiply by 4 to annualize. All right, time weighted rate of return, and people have issues with this. Several of you sent me questions related to time weighted rate of return. So I will explain the concept, and then I'll also explain the sorts of issues that some of you have had. The time weighted rate of return measures the compound growth rate of $1 invested initially, and then you basically look at the rate at which that $1 is growing. Now this is an example from a regular lecture where we've made a simplification that cash flows are only happening, or our investment period is 2 years, and cash flows are happening either at the start or end of every year. Okay, now the time weighted rate of return or the money weighted rate of return is always expressed in an annualized number. All right, so in this case, we come up with an annualized return for period 1 based on the fact that you invest 22, and at the end of the year, the 22 becomes 22.50 share price plus a dividend of 50 cents. So your $20 became so became 22.5 plus 0.5. If you invest 20 and at the end of the year the stock is worth 22.50 plus there is a dividend, 23 divided by 20. What you should actually have is $1 becomes 1.15. And then what's the rate for the second year? What's the return over the second year? In the first year you had $1 become 1.15. In the second year you buy a stock for 22.50. At the end of the year that stock is worth 23.50 plus you get a dividend of 50 cents. So you essentially in the second year have 24.00 and your investment was 22.50. So when you do that division, 24 divided by 22.50, you get 1.067. The time-weighted return then is the geometric mean or the geometric average of these two numbers. Now, here is the issue that some people had. There are some practice problems in past mock exams or practice problems on your CFA Institute website where you are given the returns for 4 quarters in a year. If you make an investment at the start of a quarter and then at the end of the quarter, and let's say that your return for the first quarter was 5%, then second quarter return was 2%, third quarter let's say return was minus 3%, and in the fourth quarter the return was say 8%. Then what do you do? Question?
No, I was saying that sometimes. But I think you are recording all that.
All right, so what you are doing here is, since this is every quarter, what is the return for the full year? Then the return would be the product, 1.05 into 1.02 into what? What does the minus 3?
0.97.
Into 0.97 into 1.08. And then the return would actually be this product minus 1. So the question is, when do we do the geometric mean and when do we not? We do a geometric mean if you have the returns for years, and then you want to say, okay, on a 1-year basis, what is the return? When do you not do the geometric mean? When you have the returns for different quarters or different months, and then you just chain them together or multiply them together to get the return for the full year. All right, so those who ask the question, does that make sense? Is it possible that we might need to do both? Let's say that you have a 3-year investment horizon where you have returns for every quarter. Then what do? You use this chain-based system to come up with the return for every year, and then you use the geometric mean for the returns for each year. All right, so those of you who have not done the practice questions on the CFA Institute website yet will come across this sort of a problem. This page summarizes the differences between money-weighted rate of return and time-weighted rate of return. The money-weighted rate of return is simply the IRR, and I actually want you to read this. This is testable because they might ask you about the differences between the two. I've highlighted these 2 points. The money-weighted rate of return is an appropriate measure if the portfolio manager has control over the timing and amount of investment. This happens a lot in private equity, whereas the time-weighted rate of return is appropriate when the manager does not have control over the timing of investments. Here is another item that people have issues with. All the different yield measures, and let's use this as an opportunity to try and remember the yield measures. The bank discount yield, remember the name has discount in it. So the bank discount yield is the discount, which essentially is the difference between the face value and the price. So specifically the discount is equal to face value minus price divided by the face value And if you are not given the face value of a bond, just assume that the face value is 100. So discount divided by face value into 360 over T. T is the amount of time to maturity. The holding period return is the overall return during a holding period of, let's say, 3 months divided by the investment. The money market yield is the holding period yield into 360 over T. And then the effective annual yield is 1 plus holding period yield into, actually raised to the power of 365 over T. This is the most precise measure. And then some people have issues with the bond equivalent yield. So just remember the statement that the bond equivalent yield for a semi-annual bond is 2 times the semi-annual yield. So you take each period as a 6-month period here, find the effective yield for that 6-month period, and then double. One category of questions involves you being given, let's say, a money market yield, and then you are asked to calculate the bond discount yield. Something I've noticed in the curriculum and in some study notes is that they give you a complicated formula which connects these. But if you really like memorizing complicated formulas, then learn them. But I think it's much better to just use these formulas. If you are given the money market yield, let's say the money market yield is 5%, and you are given that it's, let's say, a 180-day instrument, then can you calculate the holding period yield? You can. If you know the holding period yield, then you can actually calculate the, let's say that you need to come up with the bank discount yield. So if you know the holding period yield, then, and you know the par value, you can come up with the price of the bond, assuming that it's a zero coupon bond. The holding period yield is known, par value is known. You can use basic mathematics to come up with the price of the bond. Then you know the discount. If you know the discount, then you can come up with the bank discount yield. And somebody asked this question, so in the next segment, I'm actually going to show you how to do this. But my advice is don't memorize formulas more complicated than this. Just understand how to solve problems using these formulas. So we'll now talk about statistical concepts and market returns. First, some quick terminology, and we've done this in our regular lectures, a quick recap. When we talk about a population, we are talking about all members of a group. So population means the average of all items in a given population. A parameter describes a characteristic of a population. So parameter goes with population. A sample is a subset of a population, and a statistic or sample statistic is based on a sample. Remember these measurement scales? They keep showing up on exams. So nominal means only the names make sense. So A is not better than B, is not necessarily better than C, it's just a grouping. Ordinal means order makes sense. So if you have A, B, and C, you can say A is better than B, which is better than C. But if A is better than B and B is better than C, the degree by which A is better than B doesn't really matter. Interval, here the degree by which A is better than B makes sense. So you can say A is better than B by 3 units and B is better than C by 2 units. And the most precise measure is a ratio scale where there is an absolute 0. Summarizing data using frequency distribution. This is a fairly straightforward point. If you are given a lot of data and you want to organize it and create a histogram or some other sort of a graphical image, what you typically do is the following. You define your intervals. So here, for example, we have defined an interval of 5 points. And then you tally the observations and count the observation in each interval. That's what's been done over here. Absolute frequency of 25 means that there are 25 items that fall within this bucket or this interval. 35 fall within this interval. Cumulative means that you are just adding up these numbers. So 60 is 25 plus 30. Relative frequency is in decimal terms or percentage terms. So this 0.25 is simply 25 over the total number of 100. Measures of central tendency, these are the various measures, mean, median, mode. Within mean, you need to understand that there are different kinds of means or averages. Arithmetic mean is the most basic, which I'm sure everybody is aware of. Geometric mean is typically done this way, and we use geometric mean when we are coming up with the average return over several years. We use this when we have time series data. And if you have a return of 10% and 20% and minus 5%, you don't just take the geometric mean of 10, 20, minus 5. What you do is 1.1 times 1.2 times 1 minus 0.05, which is 0.95. And all this is raised to the power of 1 over n. N in this case is 3, the number of items. And then minus 1 to get the actual return. Harmonic mean is calculated this way, and rather than giving you the formula, I'll just show you a very simple example. If you have three numbers, 10, 12, and 15, to do the harmonic mean, you take 3, because you have three numbers, divided by the reciprocal of each of these. So that's how you come up with harmonic mean. Generally, if you have different numbers, then the arithmetic mean will be larger than the geometric mean, which will be larger than the harmonic mean. The median is your central number, and the mode is the number that shows up most often. Question?
Harmonic mean can also be calculated by P1 minus P0 plus D dividend maybe.
So this is how the simplest way of calculating the harmonic mean is this. I think what you're talking about is a holding period return. The only link between harmonic and holding period return is that they both start with H. Other measures of location. So a general term here is quantiles, and then there are different types of quantiles. These are the terms that you need to remember. When we say quartiles, then we are dividing our distribution into 4 parts. Quintiles means dividing into 5 parts, deciles into 10 parts, percentile means you divide into 100 parts. And how do you do this? Let's go with a simple example where you are evaluating the returns of 10 different mutual funds. So you organize from 1 to 20, where 1 is the worst return and 20 is the best return. And then if you do quartiles, then the first quartile will be the first 25%, second quartile will be the next 25%, and so on. Location, again going with the same data. So this is your first item, the lowest return, going to 20, the highest return. For a given percentile, let's say that percentile is denoted by y, and for n data points, in our example we have 20 data points, the location, so if we say the location of the 10th percentile, that 10th percentile is shown here, is given by n plus 1, and what is n? It is the number of observations. N plus 1 into 10, what is this 10? This is the percentile divided by 100. So you get 2.1. Now you might say that out of 20, the 10th percentile should just be 2. But we get 2.1. And the reason is that when you have a small sample size, such as this, relatively small sample size, then this formula is just an approximation. The formula becomes more precise as the sample size becomes large. If your sample size is 2000, then this will be more precise. But from an exam perspective, this is the formula that you need to remember. Linear interpolation is used when Ly is not a whole number or integer. So if we say 6th decile, then you'll get a location of 7.2. So what do? You look at the 7th value and the 8th value, and then go 20%, actually 0.2 would then mean that, and let's just do this with an example. 7th value is 37, 8th value is 39. Then the 6th decile, which is what we are working with over here, is 34.7, which is 0.2 times the linear distance between the two. And where is this 0.2 coming from? It's the 0.2 from here. Next item is measures of dispersion. How spread out is our data? The most basic measure is range, which is high value minus low value. Another measure is mean absolute deviation. There is a formula for this, but I would prefer that you think of it intuitively based on the definition. So average of the absolute values of deviations from the mean. So you find the mean, and then you find all the deviations from the mean, take the absolute values, which means that minus numbers become plus numbers, and then you find the average of those deviations. And you can do that with these numbers, and you should get a mean absolute deviation of 7.5. Population variance is the mean of the square deviations from the mean, and this is the formula for a population variance, but I want you to use the calculator, and I'll show you how to do this on a calculator. Sample variance is the same formula, but we divide by n minus 1. And this is using the calculator to come up with the variance. So just what I'll do is pause here for a moment, and you need to be able to plug in these numbers. So data means you get into data mode, and then clear everything. 10 enter is the first item, enter the rest of the data. Then you go into the stat mode, and when you go into stat mode, if you don't see this one variable denotation, if you don't see one variable on your screen, then hit second set until you get into one variable mode. Then you, as you hit down arrows, you will see n equals 4, x equals 10. Sx refers to the sample standard deviation. This refers to the population. Obviously, the calculator doesn't know whether you are plugging in a population or a sample. That you have to figure out based on the question. Now, what if you are asked for the population variance? You just take this and square it. Next item is Chebyshev's inequality. This states that for any set of observations, the proportion of observations within k standard deviations of the mean is at least 1 minus 1 over k squared. So what is k? It is the number of standard deviations from the mean. And an important point is that Chebyshev's inequality does not assume anything about the underlying population. Many other formulas assume that the underlying population is normal, but Chebyshev does not. In accordance with the Chebyshev inequality, 88.89% will lie within how many standard deviations of the mean? Now, you can plug and play over here. The two most common items are k equals 2, which means 2 standard deviations from the mean, and k equals 3. So you should almost memorize this. What percentage of your data will be within 2 standard deviations of the mean? It will be 1 minus 1 over 2 squared, which will give you 0.75. So that means 75% of your data will be within 2 standard deviations of the mean. And if k is 3, then you have 1 minus 1 over 9, and that gives you this number. So this says that 88.89% of your data will always be within 3 standard deviations. Or the more precise way of saying it is that at least 88.89% of your data will be within 3 standard deviations of the mean. Can you have 99% of the data within 3 standard deviations? Of course you can. In fact, if the distribution is normal, then you do have about 99% of the data within 3 standard deviations of the mean. Can you have 100% of the data within 3 standard deviations of the mean? Yes. And you can have a population where all your data is within. It is possible. It doesn't have to be the case, but it is possible. Chebyshev is simply saying that at least this much is within so many standard deviations of the mean. It's not telling you the upper limit. Coefficient of variation and Sharpe ratio both are very important, and in a sense they are roughly speaking reciprocals of each other. Coefficient of variation tells you the risk measured in standard deviation divided by return. So it is the risk per unit of return. A low number is good because a low number implies low risk per unit of return. So if you are comparing investments based on the coefficient of variation, you pick the one that has a lower coefficient of variation. The other is the Sharpe ratio, which tells us the excess return. By excess return, we mean the return above the risk-free rate divided by the risk. Here again, risk is measured as standard deviation. Symmetry and skewness. So this is a symmetric distribution. A symmetric distribution has a skewness equal to 0. That means you have the same amount of data on the right, same amount of data on the left. Your normal distribution is symmetric. So you'll have 50% to the left and 50% to the right of this central point. Positively skewed means that you have a fat tail on the right. A negative skew means that you have a fat tail to the left. A very testable item is that with a positively skewed distribution, the mean will be higher than the median, which will be higher than the mode. So this is the mean. And the reason is that these outliers have the largest impact on the mean. So always think of the outliers as pulling the mean the most. They also pull the median, but not as much. And they don't really have much of an impact on the mode. And then obviously with a negative skew, with a negative skew, we have the opposite. The mean is most to the left because again, now the outliers are on the left. From a risk management perspective, what sort of skew will be most dangerous? Obviously, this will be the most dangerous because there is a chance of huge negative returns. Skewness tells us how distribution is spread to the left and right of a center. Kurtosis tells us about how high or how fat a given distribution is. So it measures the degree to which a distribution is more or less peaked than a normal distribution. And you don't need to get too hung up with this, just a few basic facts. A normal distribution is mesokurtic, so it has a kurtosis of 3, just remember that. Leptokurtic means that kurtosis is more than 3, and platykurtic is k less than 3. The way you can remember platy is it comes from plateau. So plateau sort of go like that. So less peaked than normal is platykurtic. Meso is sort of the middle ground. So normal is somewhere in the middle. So that is 3. And the one that is other than meso and platy is leptokurtic. Leptokurtic means it is higher than normal, but the scary part is that it's fatter than normal. The tails are fatter. If the tails are fatter, that means they are more risky. With a fat tail, that means the probability of negative returns becomes more. All right, coming now to probability concepts. A lot of people have issues with probability. All right, there's a question on Sharpe ratio. Yeah, so with Sharpe ratio, higher the better, because Sharpe ratio is excess return per unit of risk. Probability concepts. So this is an area that many people have issues with, and later in the next segment I'll go over some probability questions. At this stage, I'll give you a couple of pieces of advice. You need to understand and remember the terminology, and you need to remember the formulas. Then when you get a question, just before you get confused by the question, just regurgitate the formulas. And then read the question carefully and then figure out which formula to use. Sometimes people read the question and then forget the formulas. So before you forget the formula, just write the formula down. and there are not that many formulas. So these are the basic terms which are fairly obvious. Very often you hear the term that these events are exclusive and exhaustive. Mutually exclusive and exhaustive means that the various events cannot happen at the same time. So if you flip a coin, then heads and tails are mutually exclusive in the sense that you can't have heads and tails at the same time. And they are exhaustive in the sense that if you flip a coin, you'll either get heads or tails. In the context of stock returns, you might say that on any given day, the stock return will either be greater than equal to 0 or less than 0. So if I define those two events, they are mutually exclusive and exhaustive. Remember these terms, empirical probability is a probability that is arrived at based on analyzing data. A priori probability is calculated by using formal reasoning and inspection, and subjective probability is less formal, it involves judgment. Remember that. Unconditional probability is the probability that a given event will happen regardless of anything else, and it's denoted like this. Conditional probability is denoted like this. This is the probability of A happening given that B is happening. The moment you see this bar, that means that it's conditional. So this is probability of A given that B has occurred. Independent events, so occurrence of one event does not influence the other, and with dependent events, knowing the outcome of one tells you something about the other. So if A and B are independent, then probability of A given B is equal to probability of A. Because if we are saying that A and B are independent and B happening tells you nothing about A, then probability of A given B will be probability of A. On this slide, I have put down all the probability rules and formulas except for the Bayes formula. Right? So at least memorize these. The multiplication rule is shown right here. And then for each formula, I have done a quick little example. Then this is the addition rule. I have already mentioned this. Independent events, occurrence of one does not influence the other. So we have talked about this. And then for independent events, the multiplication rule becomes this. So if I have a die and I roll it once, and then I roll it again, are those two events independent? Yes, because the first roll has nothing to do with the second roll. So if the first event is getting a 6 and the second event is getting a 6, what's the probability of getting a 6 and a 6? It is 1 over 6 multiplied by 1 over 6. So the multiplication rule becomes quite straightforward when we have independent events. And this is the total probability rule, where we say the following: the probability of a given event, is this independent or dependent? Probability of A?
Independent.
It is independent. The total probability rule allows you to use dependent events. So you say you are given dependent events and you need to compute the probability of an independent event. That's where you use the total probability rule. So if you have scenario S, which is the economy will be good, and scenario not S, which is the economy will not be good, are S and SC mutually exclusive and exhaustive? Yes, the way I've defined it, they are. Then you can use this. You can say probability of A given S into probability of S plus A given not S into probability of not S will give you probability of A. If I have 3 different scenarios, then instead of having 2 terms, there will be 3 terms. And we'll see this in the next segment where I'll do some questions involving this rule. But again, I'll reiterate, the moment you see a probability question, first thing that should go through your head is this Bayes formula or not Bayes formula? If it is not Bayes formula, then write down the multiplication rule and the addition rule before even trying to figure out which rule to use. And I say that because very often the way the questions are worded, they tend to be confusing, but you write down the formulas, you write down the data in terms of these symbols, and then given the data and given the formulas, you need to figure out which formula to use. and obviously that will come with some practice. Next point has to do with computing expected value and standard deviation of a random variable. Now you might think that you've sort of done this, but there is a difference. In the earlier discussion on standard deviation and variance, what we said is that we are given a data set. You plug the data set into a calculator and you came up with the standard deviation. Now the difference is that let's say that you have a variable such as a cash flow, where the cash flow depends on the state of the economy. Each state of the economy has a probability. So there's a 0.3 probability that the cash flow will be 50 and so on. Now, does this cash flow have a variance or is it constant? Clearly it has a variance, but each of these cash flows is not equal probability. There are different probabilities. When you have different probabilities, you can still calculate the expected value and variance. Expected value is simply 0.3 into 50 plus 0.5 into 40 plus 0.2 into 20. And the variance is a measure of how spread out this data is. And I would recommend that you do this using the calculator. There is also a formula for this, but this slide essentially shows you what you need to plug in, and that is going to give you both a sample and a population variance. And this, by the way, is a population. And how do we know that? Because we are defining that there are only 3 possible states of the economy, and we are given the cash flow for each state. So this covers everything and is therefore a population. Covariance, correlation, portfolio return, and risk. The covariance is a measure of how two variables move together. Values range from -infinity to +infinity, and this is the formula. Later I will do a question where we calculate the covariance. This looks long-winded, but I'm quite sure that if you get this on the exam, it will be based on relatively straightforward numbers. So later we'll see how to use this formula. The issue with covariance is that it spans from -infinity to +infinity. So if you have a covariance of 38, you know that it's positive, you know there's a positive relationship, but you don't know whether you have a strong positive relationship or not. In order to figure that out, you need correlation, which is a standardized measure of covariance. So the correlation is the covariance divided by the standard deviation of each of the variables. This is the expected return, which I've talked about before. It is simply a weighted average of the returns of, let's say, 2 different stocks. And then this is the variance of returns of a portfolio. You need to remember this formula. And in one of the examples in a video that I've already shared, this has been calculated. This material also shows up in portfolio management, so it is important. Okay, now coming to everybody's favorite topic, Bayes formula. Many people have issues with this, and later I'll do a couple of questions related to Bayes formula. In the picture that I showed you earlier, the one that looked like this, I would not put Bayes formula over here. It is somewhat difficult. I'd put it a little later, but I still like to cover it because it deals with many of the probability concepts that we've talked about, especially the total probability rule. I'm not going to explain this in detail now, but in case it shows up, I'll tell you how to deal with such problems. The first thing that you do is you remember this formula. Probability of event given information is equal to, the starting point is the original probability of the event, and then you are going to change this based on the new information. And how do you change it? By multiplying the original probability of the event by probability of information given event divided by the unconditional probability of the information. Very often you will not be given this, but you will have to use the total probability rule to come up with probability of information. And typically this will be given and this will be given. Now in the next segment I'll actually make you do 2 questions, but for now I will emphasize that at least memorize this formula. Even if you don't thoroughly understand Bayes formula, then knowing the formula can help you answer most questions.
So sir, in the exam, is it bias for your questions, we use the tree diagram, because if we use the tree diagram, then it will be less complicated. Because
Okay, so the question is on the Bayes formula, do we use the tree
we
diagram?
can use that.
We can. My response to that is that different people find different things easy.
Yeah.
So if you like the tree diagram and that helps you answer, I know some people like doing it that way, then go for it. So you have to practice and figure out what works for you. Okay, next, permutations and combinations. Here again, I strongly encourage you to use the formula. When we talk about permutations, NPR, or let's just say that in a portfolio of 8 stocks, then N would be 8, and we want to choose 3 of those stocks to sell, and the order matters. Let's say that if you start selling, there'll be a huge issue. So the order in which you pick the 3 from 8 matters. When the order matters, then we have a permutation. So the formula would be 8 factorial divided by 8 minus 3 factorial. But rather than use this formula, I want you to use the calculator. So the way you do this is you plug in the 8, then second, then this NPR, and then you plug in the 3. So that will give you the answer. With combinations, the order does not matter. So if you are doing a 6C4, then you do a 6, second, and NCR is right here, and then 4. So use your calculator.